Hello class, Mr. Sutton here. Today we're going to be talking about skill 14, writing and graphing systems of inequalities. So, system of inequalities is like a system of equations in that we have two or more inequalities that make up the system, and then when you graph them, you can see where they intersect, and for inequalities, if you remember, you have to shade on either side of the line. So for inequalities, our solution is where the shading overlaps. So in this case, it would be in this purple region here and along this red line because that's a solid line. So that means the points are included there, but not along this dotted line because dotted means that the points there are not included as part of the solution. So that would be the area here, if I could outline it. It would look like that, except it would continue on out in this area as well. So for this first type of question, it says which point would not be a solution to the system of linear inequalities shown below. So we have 4 different points here. 3 of these will exist in that overlapping set of solutions that I talked about in the last slide. 1 of these does not. So the way we figure out if it exists in that overlapping set of solutions or not is we plug our potential solutions here into both inequalities and we see if we get a true statement or not. So first I'm going to plug in this 0, 10 into both inequalities and see if I get true statements or not. So this is what it would look like if I plug this coordinate into both of these inequalities here. So this y is greater than negative 5 halves x plus 6 would become 10 is greater than negative 5 halves times 0 plus 6. So we plug in 0 in for x, 10 in for y. And then here we plug in 0 in for x, 10 in for y for this inequality. So that become 10 is greater than or equal to 3 times 0 plus 1. So now I'm going to go ahead and simplify these two inequalities and see if they end up giving me true statements or false statements. So negative 5 halves times 0 is 0. 0 plus 6 is 6. So if 10 is greater than 6, that is a true statement. True. Over here, we have 3 times 0 is 0. 0 plus 1 is 1. So if 10 is greater than or equal to 1. Also a true statement. So this first point, since it's true for both of these inequalities, that means it is a solution to the system of linear inequalities, which we're looking for the one that's not a solution. So this one is a solution, so that's not going to be our answer. So let's go ahead and try this 10, 8 next. So this is what it would look like if you plug in the 10 in for the x and 8 in for the y for both these inequalities. So you get 8 is greater than negative 5 halves times 10 plus 6, and 8 is greater than or equal to 3 times 10 plus 1. So now I'm going to go ahead and simplify these two inequalities and see if I get true or false statements. So negative 5 halves times 10 is negative 25, plus 6 is negative 19, so 8 is greater than negative 19, that is true. 3 times 10 is 30, plus 1 is 31. 3 is greater than or equal to 31. That is not true. 31 is greater than 3. So this coordinate here was true for this inequality, but not true for this one. So what that means is it's a solution for this, but not a solution for this, meaning it's not a solution for both. For it to be a solution to the system, it has to be true for both. So that means this is going to be our answer here. This is the one that is not a solution to the system. So it has to work for both of these. But we can go ahead and check the other two examples while we're here just to make sure. So for 0, 8, we got 8 is greater than negative 5 halves times 0 plus 6. Negative 5 halves times 0 is 0 plus 6 is 6. 8 is greater than 6. That works. For the other inequality, we have 8 is greater than or equal to 3 times 0 plus 1. 3 times 0 is 0 plus 1 is 1. 8 is greater than or equal to 1. That works. So 0, 8 is a solution to the system. So it's not our answer here because we're looking for one that's not a solution. Now 2, 8, plugging it into this equation here, we have 8 is greater than negative 5 halves times 2 plus 6. Negative 5 halves times 2 is negative 5. Plus 6 is 1. 8 is greater than 1. That works. 8 is greater than or equal to 3 times 2 plus 1. 3 times 2 is 6. Plus 1 is 7. 8 is greater than or equal to 7. That works. That is true. So 2, 8 is true for both of these inequalities as well. So that means 2, 8 is a solution to this system. I mean, it's not what we're looking for. So yeah, this is our final answer here. 10, 8. That's the only one of these that is not a solution to the system because it was true for one inequality, but not true for both. So it is not a solution. Now let's go ahead and look at this next part. Below are two inequalities and the graphs of their lines without the shading. By imagining where the shading should be, identify which point would satisfy both inequalities. So a little reminder of how shading works. If it's less than, you shade below the line. If it's greater than, you shade above the line. So let's look at these. These are both less than. So our line with a negative 2/3 slope is this one right here. That's the negative slope. So if we think about where that shading would be, it's less than, so it would be below this line. So that would mean it would be shading here. And then this other line, this positive 1/2 line right here, the slope of positive 1/2, also has shading below. So I'm going to shade in the other direction for this line. So we can see that the overlapping region is this right here. That's where they're both shaded. Over here, we only have one shading. Over here, we only have one shading. They're both shaded right here. So we want to look for points that exist in this area right here. So, and we have 4 points to choose from. So I went ahead and identified where those points are. -3, -10 is right here. So we can see that that is in the overlapping region here, the double shaded region. 10, -3 is right here. So that's only in a single shaded region. So that is not a solution. Only satisfies one of our inequalities, does not satisfy both. Not a solution. -3, 6 is not in either shaded region. So that's definitely not a solution. And then -8, -6, again, that's only in one shaded region. It's not in the overlapping shaded region. So it only satisfies one inequality, not both. So the only one that satisfied both was this one right here. That is -3, -10. All right. So that's your other type of problem here. All right, here's another type of problem. Solve the following system of inequalities graphically on the set of axes below. State the coordinates of a point in the solution set. So we want to graph our two inequalities, and then we want to pick a point that's in that overlapping region. So I'm going to go ahead and start graphing y is greater than -5/2 x minus 1. So here's my coordinates for that inequality. Y-intercept of -1 and a slope of -5/2. So we're rising -5 running 2, or rising 5 running -2, rise 5 run -2. So it should look something like this. I'm going to go ahead and draw in, this is going to be a dotted line because there's no equal to part. So it should look something like that. I'm going to save the shading for a little bit. I will shade above, which will be in this area, but I don't want to mess up my second line yet. So I'm going to save that for later. Now I'm going to go ahead and plot the points for my second line. Y is less than 1/2 x minus 7. So there are the points for that line. So y-intercept of -7, slope of 1/2. So rise 1, run 2, rise 1, run 2, rise 1, run 2, or rise -1, run -2 in the other direction. Right, so it should look something like that. Once again, it's going to be a dashed line because there's no equal to. So I'm going to go ahead and draw that. Make sure you don't forget your arrows if you're drawing these on paper. So this line we would be shading below. So we got to figure out where our overlapping region is. So for our line with a negative slope, we're shading above, so that would be up here. And the line with the positive slope, we're shading below, so that would be down here. So the overlapping region would be in here. And you want to pick a point that's pretty solidly in that region. Any point in this region will do. So I'm going to say 10. Let's go just 10, negative 10. That'll work. That's right there. So 10, negative 10 is in this double shaded region. So that is part of our solution set. State the coordinates of a point in the solution set. So 10, negative 10 would work for that, but any point in this double shaded region would work. 9, negative 6 would work. A lot of points you can choose from. So next type of question, this is a story question. So here we would have to come up with our own inequalities here given the context. So Juan is working 2 summer jobs, making $12 per hour babysitting and making $16 per hour lifeguarding. In a given week, he can work at most 17 hours and must earn at least $240. If Juan worked 3 hours babysitting, determine all the possible values for the numbers of whole hours lifeguarding that he must work to meet his requirements. Your answer should be a comma separated list of values. If there are no possible solutions, submit an empty answer. So to write our system of inequalities, we just need up to here. That gives us everything we need to know. So once we get to if Juan worked 3 hours babysitting, that is more information than we need to write our system. So starting with this, we want to think about first what variables we want to use. So I'm going to say x is hours babysitting and y is hours lifeguarding. Now I chose hours because hours relates to both equations we're going to do. We're going to have a equation regarding money, which his money is based per hour, and we're going to have another equation just regarding time because he can work at most 17 total hours. So our money equation would be something, or our money inequality, would look something like this. So it's the number of hours babysitting multiplied by $12 per hour, number of hours lifeguarding multiplied by $16 per hour. And then our inequality is going to go here, and we're going to set that up against 240. Now we got to figure out what inequality we're going to use here. It says he must earn at least $240. So this part over here is the amount of money he's earning. So if we want this to be at least $240, we're saying it can equal $240 or it can be greater than $240. So this is our inequality here. We're saying this amount that Juan can earn is greater than or equal to $240. So now we want to come up with our inequality that we're going to use to represent the amount of time. It says he can work at most a total of 17 hours. So we can represent our total time by just saying x plus y, hours babysitting plus hours lifeguarding. And we want that to be at most 17 hours. So it can equal 17 hours or it could be less than 17 hours. All right, so this is the amount of time Juan is working. And we want that to be less than or equal to 17. Now let's go ahead and take a look at the rest of the problem. It says if Juan worked 3 hours babysitting, determine all possible values for the number of hours lifeguarding that he must work to meet his requirements. So we are saying x equals 3 at this point. We're setting x to equal 3. So now we want to plug that in and figure out what possible values of y we could have. So plugging y into this first inequality, or plugging 3 in for x into this first inequality, We have 12 times 3 is 36, plus 16y is greater than or equal to 240. Subtract 36 on both sides, and you get 16y is greater than or equal to 204. Divide by 16 on both sides, you get y is greater than or equal to 12.75. So 12.75, y needs to be greater than or equal to that in order to make $240. So he needs to work 12.75 hours at least in order to make that amount of money. So let's go ahead and plug in 3 for x in our other inequality here. So if you plug in 3 for x, you get 3 plus y is less than or equal to 17. Subtract 3 on both sides, and you get y is less than or equal to 14. So combining these two answers, we would have 12.75 is less than or equal to y is less than or equal to 14. Anything between those two values or including those two values works. Now, let's look back at how this, once our answer, so it says determine all possible values for the number of whole hours lifeguarding that he must work to meet his requirements. Your answer should be a comma-separated list of values. If there are no possible solutions, submit an empty answer. So if we want whole hours, we can't say 12 because 12 would not exist between these. So we gotta think about the whole hours that exists within this parameter, and that would be just rounding up to 13 and then 14. So our comma separated list of whole hours that is included in this range here would be 13 comma 14. So that would be our final answer for this one. All right, last type of problem here. The drama club is selling tickets to their play to raise money for the show's expenses. Each student ticket sells for $5 and each adult ticket sells for $8. The auditorium can hold at most 150 people. The drama club must make at least $960 from ticket sales to cover the show's costs. If X represents the number of student tickets sold and Y represents the number of adult tickets sold, write and solve a system of inequalities graphically and determine one possible solution. So I'm going to say X represents students, Y represents adults. We're going to have two inequalities. One will represent the amount of people and one will represent the amount of money. So for our money inequality, we have $5 per student plus $8 per adult. And we want to make at least $960. So this is how much money we're making. So this can equal $960 or it can be greater than $960. But this has to be at least $960. So this must be greater than or equal to $960. As far as the number of people, number of students plus the number of adults, needs to be at most 150. So this can equal 150 or it can be less than 150. So these are our two inequalities. So now we want to graph them. In order to graph them, we need to write them in y equals mx plus b form. So y inequality mx plus b are slope-intercept form in order to graph them. So I'm going to go ahead and do that now. So first inequality, subtract 5x on both sides, and then you have 8y is greater than or equal to negative 5x plus 960. Divide both sides by 8, so then you have y is greater than or equal to negative 5/8x plus 120. That is in slope-intercept form. For the second inequality, all you have to do is subtract x to the other side. So you should get y is less than or equal to negative x plus 150. Next step is to graph both of these inequalities. So I'm going to go ahead and graph this first one. Notice that we're only looking at the first quadrant here because both of these values should be positive. We can't have a negative amount of students or adults. So I'm going to go ahead and graph this first one. So it should look something like this, and we're going to shade above. One thing to note is the scale. So since we are counting by tens here, the slope negative 50 over 80 is the same as negative 5 over 8. So you can go ahead and count units the same way you normally would. Sometimes you'll have a weird scale, though, where things might be stretched out in a different way. So take note of that. Second inequality, I'm going to go ahead and graph that. So that should look something like this. We have a y-intercept of 150 and a slope of -1. So it just goes down like that. And for that, we're shading below. So if we're above this line, below this line, our solution set would be right in here. Right? So one possible solution would be 10 students and 130 adults. All right. But other possible solutions in there. So that is the final example here. If you have any questions about any of that, make sure you are coming to office hours or asking for help in class. Have a good day.